Pentaho Data Integration, or PDI, is a comprehensive ETL platform allowing you to access, prepare, and derive value from both traditional and big data sources. During this lesson, you'll be introduced to Pentaho MapReduce, a powerful alternative to authoring MapReduce jobs that will reduce the technical skills required to use MapReduce, improve productivity, and has demonstrable performance advantages over alternative authoring approaches such as Hive, Pig, and hand-coded MapReduce jobs. Pentaho MapReduce jobs are designed from the ground up using Pentaho Data Integration's easy-to-use graphical designer, and the resulting jobs leverage the data integration engine running in cluster for maximum performance. In this lesson, we will recreate the standard word count MapReduce example using Pentaho MapReduce, beginning by creating a new job and adding start entry onto the canvas. Jobs in Pentaho Data Integration are used to orchestrate events such as moving files, checking conditions like whether or not a target database table exists, or calling other jobs and transformations. The first thing we want to do in our job is copy the input files containing the words we want to count from our local file system into HDFS. The Hadoop copy files entry makes browsing HDFS as simple as working with your local file system. We'll first specify the folder on our local file system from which we'll copy our word count input files. Next, we'll specify the target copy location in HDFS. Finally, we'll define a wildcard expression to grab all of the files in our source directory that contain the word README and click Add and OK. Now we'll add the Pentaho MapReduce job entry into the flow. Opening the entry editor, you can see that configuring a Pentaho MapReduce job entry is as simple as specifying a Pentaho data integration transformation to use as the mapper, one for the reducer, and optionally configuring and choosing one to act as the combiner. Since we have not designed our mapper and reducer transformations yet, we'll save our job here and pause to go create them. Next, we'll design the transformation to be used as a mapper in our word count example. Any transformation that will be used as a mapper, combiner, or reducer will need to begin with the MapReduce input step and end with the MapReduce output step. These steps are how Hadoop will feed key value pairs for processing into our transformation and how the transformation will pass key value pairs back to Hadoop. As key value pairs are fed into this transformation, the first step we want to do is split the strings coming in as values into individual words that we can then use for counting. For this, we'll use the split fields to rows step. The field to split will be our value field. We'll split the words based on a space character, and we'll name the resulting field containing the individual words word. This new word field will be used later as our key field for the reducer part of the Pentaho MapReduce job. Next in our transformation flow, we'll want to add a new field containing a value of 1 for each individual word extracted. This field will represent our values during the reducer phase of the Pentaho MapReduce job, used to aggregate the individual instances of the word from our input files. For this, we'll use the add constants step to create a new field called count, with a data type of integer and a constant value of 1. Finally, we'll connect add constant step to the MapReduce output step and configure it to use the new fields word and count as our keys and values to be passed back to Hadoop. We've now completed a mapper transformation that will read in key value pairs, split the incoming values into individual words to be used as our new keys, added a constant of 1 for each individual word found that will be used as our values to aggregate during the reducer phase. Let's save our transformation and move on to designing the reducer transformation. The reducer transformation will be very simple. We'll create a new transformation and add our MapReduce input and MapReduce output steps. The only business logic we need to add is to aggregate each of our values for the key fields being passed in. For this, we'll use the group by step. Our group field, in this case, will be our key field. We'll name the field that will contain our aggregates, sum. The source column, or subject, will be the value field, and the type of aggregation we'll perform is sum. Now, this step is configured to group all of the common keys together and create a field called sum containing the total of all values for each instance of a given key, resulting in the total count for how many times a given word appeared in our input files. We're now ready to save our reducer transformation and return our Pentaho MapReduce job and point it at our newly created mapper and reducer transformations. Let's reopen the Pentaho MapReduce job entry. First, we'll provide a name for the Hadoop job. Now we'll point the mapper at our word count mapper transformation by selecting the transformation and specifying the steps within that transformation that represent the Hadoop input and output steps. And now we'll point the reducer to our word count reducer transformation, again by selecting the transformation and specifying the steps within that transformation that represent the Hadoop input and output steps. Next, we'll configure our input and output directories for the Hadoop job on the Jobs Setup tab. The input path will be the path we configured to copy our input files to in the Hadoop copy step, and we'll use word count output as the location to output our results. Pentaho MapReduce will support all common formats for input and output data. For this example, we'll use the simple text input format and text output format, and we'll select the option to clean output path before execution. Finally, we need to point to the Hadoop cluster on which we want to run the Pentaho MapReduce job. We're now ready to save our finished job, run it, and view the results. We'll run this job locally, and as the job is executing, we can view the status of the job through feedback gathered from the Hadoop cluster. Congratulations, you have now completed your very first Pentaho MapReduce job. To find out more information about the powerful Pentaho platform, or to start your free proof of concept with your very own data with the help of our expert sales engineers, you can contact Pentaho at pentaho.com.